Assalamualaikum and a very good morning to all viewers who is now watching through Zoom as well as Facebook Live. Before we start, on behalf of Stormwater Division, I would like to take this opportunity to welcome everyone and wish thank you to the Corporate Division, who is the secretariat of this webinar session. Well, allow me to firstly introduce myself. My name is Razlan bin Saleh, Senior Assistant Director from Stormwater Division, and I will be the moderator for today. I'm sure that when you all hear the Stormwater Division, first thing that came into your mind will be MSMA, but today we will not talk about MSMA, but we will talking on stormwater management and drainage master plan study, which is also known as Pisma. Before I pass the session to our invited speakers, allow me to give a general overview on Pisma. As we know, the planning of a stormwater system has moved significantly away from traditional concrete line channels emanating from the Depression era. Considerable use has been made of retarding basins to mitigate increased flood peaks due to urbanization and massive land opening for agricultural and other related activities. Grass floodways have largely replaced concrete channels to slow flow velocities and provide greater visual appeal and passive recreation areas. In addition, over recent years, there has been an attempt to intercept a range of non-point source pollutant, including agriculture and domestic waste, general litter, sediment and nutrients, etc., utilizing stormwater-based management practices, including gross pollutant traps, water quality and quantity control ponds, swales, and rain water harvesting system. There is also an increasing awareness of the ecological values of water courses and the need to maintain and enhance these values. Due to this reason, the ID Malaysia, through Stormwater Division, has started to prepare Pisma for certain town area, which then will be beneficial for management and planning by state DID, local authorities, and other relevant agencies. Pisma is mainly trying to achieve three main objectives, which will be focusing on formulating master plan for water quantity, water quality, and asset inventory. Ladies and gentlemen, therefore, to talk on Pisma on this morning, I would like to welcome two very expert speakers, Ms. Karen Wong Kong Ying, Principal Assistant Director of Stormwater Division, DID Malaysia, and Engineer Judy Kue Ju Keng, Hydraulic Engineer from JNP Professional Sarawak Sdn Bhd. So, good morning to everyone. Just a short brief of the background of the speakers. Ms. Karen gained her degree from University Tenaga Nasional Unit 10 and later pursued her study in Master in Science in Civil Engineering, majoring in Marine Structures from the Technical University of Denmark. She has 15 years working experience in the government, which includes Coastal Management Division, the ID Penang, and Stormwater Division. Meanwhile, Engineer Judy Kue Chu Keng gained her civil engineering degree from University Technology Malaysia and later pursued her study in Master of Business Administration from Wawasan Open University. She also has 15 years of working experience and currently working with GNP Professional Sarawak Sdn Bhd, where she mainly involved with water study and projects such as water resources, flood mitigation, and etc. for government and private sector. So before we start, just a gentle reminder to all viewers, if you have any questions, you may ask through the chat box in the Zoom or leave your comment in the Facebook. Thank you. With this, please join me to invite Ms. Karen Wong Kong Yin, followed by Engineer Judy, to give their presentation. Please welcome.
Okay, thank you. Thank you, Engineer Razlan, our moderator today, for your introduction. So I will first share my screen. Okay, so good morning, ladies and gentlemen. My name is Karen Wong. I'm the Chief Assistant Director in Division of Stormwater Management Department, Division, and at the Department of Irrigation and Drainage Malaysia. Today, Engineer Judy and I would like to share information on Kajian Pelan Induk Saliran Mesra Pisma di Malaysia. So for our presentation outline today, I will start the presentation with introduction, and Engineer Judy will present the findings of Kajian Pelan Induk Saliran Mesra Serian, Sarawak, and finally I will come back with a brief conclusion. So as an introduction, okay, as we know, Malaysia received 2,496 millimeter or 971 billion cubic meter of rainfall annually, which is approximately 3 times compared to the global average, 830 millimeter. So Malaysia, as a developing nation, is facing numerous issues and challenges in order to ensure water security in the country. So the main water issues are, as I show on the screen, too much of water. In certain time of a year, too much of water in the country will cause flooding in the country due to heavy downpour or continuous rainfall. So for your information, for the past 5 years, we have recorded more than 500 flood events each year. Second main issues, too little water. At certain period of time of the year, reduction in rainfall causes like shortage of water in our dams, and this will further cause shortage of water supply. It was reported that El Nino has reduced and has caused rainfall reduction up to 50%. And the third issue in our country, too dirty. Approximately 300,000 tons per year of rubbish were recorded thrown into the drainage system or the river system, and this caused pollution of water bodies. Next, I would like to focus in flood in Malaysia. As most of us may learn from the history, in 1926, the Red Flood has destroyed lowland forests affecting the entire of Peninsular Malaysia. In 1971, catastrophic flash flood in Kuala Lumpur has caused 24 deaths, and DID, after this flood event, DID was assigned by the government to lead flood control in the country. So in 1996, Tropical Storm Greg in Sabah claimed 241 lives and $97.8 million of damage. In year 2000, 15 people killed in Kelantan, Terengganu, and 100,000 people in. This slide reports flash flood event from 2018 to October 2021. So I would like to say that flash flood occurs in all states in Malaysia, in which that we need to do something to solve this problem in the whole country. So before we start to do anything physically to solve the problem, let us look at what are the main causes of flash flood. So first, flash flood occurs due to very high intensity, short duration of rainfall. It is also due to rapid and high density of urban development. When a city is developed, somehow we forgot or we did not upgrade the existing drainage system. So the existing drainage system become under capacity. In some cases, due to budget constraint, the existing system was not well maintained or improved. So backflow of the water from downstream will cause flash flood. Besides, severe erosion and sediment wash off from construction site will flow into water bodies. So it's not surprised to see that we see clogging of drainage system by sediment, rubbish, and debris. Another main causes of the flash flood is due to shortcoming of MSMA implementation. So regardless, it's due to lack of public awareness or enforcement, or lack of understanding, or lack of data, or lack of integration. We should solve this problem together. Okay. In general, when we talk about water management strategies, Integrated Water Resources Management, IWRM, is a regional scale management. Integrated IWRM is an approach to manage water that looks holistically at the planning and management of water supply, wastewater, and stormwater system. So when we look at basin scale management, we will RRBM, Integrated River Basin Management, is a basin scale management where multiple agency works within the water boundary for optimum benefits to achieve four main objective of RRBM is ensure sufficient water, ensure clean water, reduce the risk of flooding, and improve the environment. So when we come to city scale management, Pisma is a suitable tool to use where the city level agency can focus on localized urban issues with long-term solution. Next, before I proceed further, let me bring you through the development of urban stormwater management practice in Malaysia. As I mentioned just now, DID was assigned to lead flood control starting from 1971 after the flash flood event in Kuala Lumpur. So in 1975, DID published the Urban Drainage Design Standard and Procedures, which promote a concept of like rapid disposal in design, in detailed design. So however, like when the development goes, in year 2000, DID published the first edition of Urban Stormwater Management Manual that we start in this MSMA, we start to promote quantity and quality control. In year 2011, DID published the second edition of the manual. And now we are working on developing the third edition of MSMA. So hopefully we can receive and we are able to publish the third edition of MSMA by the end of Malaysian Plan number 12. Okay, looking back into the source of power, like how MSMA came into the picture, it was started in year 2001 in cabinet meeting, agreed MSMA as a condition for the approval of development plans involving drainage in infrastructure in all federal, state government, and private sector. In year 2005, MNKT agreed ESCP as a mandatory requirement in submitting earthwork plans for the purpose of applying for planning permission to all local authorities. In year 2007, MSMA as a key condition for all land development application for residential, industrial, and commercial development to one-stop center, OSC, by the local authorities. So in coming near future, MNKT will recommend Pisma to be referred in all development planning. So MSMA, Urban Stormwater Management Manual, MSMA, is provide guideline for professional, especially engineers, to plan environmental friendly drainage infrastructure through the concept of quantity and quality control at source level. So in MSMA, we focus on quantity control. So which when we say quantity control, it means post-development peak at any ARI at the project outlet must be less than or equal to the pre-development peak flow of the corresponding ARI. We always say that Q post have to be less than Q pre. So the second concept of MSMA is on quality control, erosion sediment control, operation and maintenance, and we focus on sustainability of sustainable of the system. Some people might be curious, what is Pisma? Pisma is Stormwater Management and Drainage Master Plan, and it is the abbreviation used for Pelan Induk Saliran Mesra. So we would like to brand the term Pisma. Pisma is master plan that comply MSMA concept. It identifies issues and weaknesses related to existing system and water quality. It proposes works to be implemented based on long-term solution to overcome flash flood and water quality issues in urban areas. Pisma provide guidance and reference for more systematic development for future. So Pisma come with three main objectives: to formulate long-term stormwater quantity management and master plan to reduce flood risk. When we talk about stormwater quantity control, we mean surface runoff should be controlled at source. We control and contain the surface water to reduce peak at river water level. We minimize impervious area, and we increase water absorption in the study area. So second objective of Pisma is to formulate the long-term stormwater quality management and master plan using best available technology and best management practice to reduce water pollution impact on water body. So when we talk about this objective, it is to reduce the pollutants before it enters the river, and we identify the point source pollution and tackle it locally. The third objective is on stormwater asset inventory system. In the Pisma, we would like to develop the stormwater asset inventory system in order to identify optimal maintenance plan to provide continuous benefit through mapping data up to secondary drain. So next, I would like to share that there is a total of 48 Pisma will be developed by the end of Malaysian Plan number 12. So up to now, 26 Pisma has been completed, 6 Pisma is in progress, and 16 more Pisma is in planning for future implementation. So for your information, the selection of Pisma, the location is based on localized issue at city level. So some Pisma are federal government funded, and some are done with the initiative of the state government. So in coming near future, Pisma will be referred in all development planning. So we would like to proceed. The presentation will continue with a case study. Kajian Pelan Induk Saliran Mesra Sarawak. For your information, the study was started in March 2020 and completed earlier this year. So without further ado, I would like to invite Engineer Judy to present the findings of the study. So Engineer Judy, the floor is yours.
Okay, good morning. I will continue with the presentation this morning. For the case study for the Kajian Pelan Induk Saliran Mesra Alam Series, which we have the privilege to involve in this study. Next. The Syrian study area basically is about 64 km square as shown in the map here. Is actually about 2.67% of the Syrian division. Syrian division actually is the 12th division in Sarawak. Is separated from the Samarahan division in 2015. So basically, if we are coming from the Kuching city, it will about 64 km from the Kuching city to the study area. If you are driving car, it will take about 45 minutes. And for the 64 km square study area indeed is located within the Batang Sadong Basin. Batang Sadong Basin actually is one of the big river basins in the Sarawak. So at the study area at the Batang Sadong Basin is about 1,000 km square. So for the study area, as we can see on the figure on the right here, on the top one, on the southern part of the study area is drained by Batang Sadong main river itself. And then on the northern portion of the study area is drained by the Batang Sadong tributary like the Sungai Rayan and Sungai Tarat. And then on the bottom of the figure is also the overall terrain of the study area. Basically, the topography is ranged from the 5 meter to about 550 meter, and then the western part actually is quite mountainous. And then for the slightly low topography can be seen on the east and southeast area, and this will be tied to the flood pond in the study area. Next. Okay, so basically there are two major problems in the study area. The first is the flood. So actually flood occur in the study area nearly every year from the December to the January months during the northeast monsoon season. As shown on the left of the figure photo here is the flood condition in this year, end of January to February 2021. So there are some of the areas is frequently flooded, like the Kampong Hulu Saliran and Kampong Hilian Saliran. And then there's another photo showing the flood condition during the 2018 and also the 2019. So basically the flood prone area is actually located at the east and also the southeast portion of the study area. And then basically the causes of the flood, of course we cannot deny. One is heavy rain, like northeast monsoon bring a lot of the rain during this period. And then another one is the poor drainage system in the study area. Some is having inadequate capacity, and then some actually the network is not well integrated, and then some also the drain type is inconsistent. Of course there are other factors like backflow from the Batang Sadong main river. Despite the study area is about 128 km square outstream from the river mouth, Saliran town center here still can feel the backwater from the river mouth and the tidal influence. Next, another problems in the study area basically will be the pollution. So pollution, there are two sources. One is the non-point source, and then another one is the point sources. Point source is the source that we can easily identify, and it will be discharged continuously. On the other hand, for the non-point source, is bring down by the rain into the ground and then subsequently to the drainage system. As we can see, some of the problem during the study is like the sedimentation is quite common. Sediment is actually settled in the drain due to the upstream there's a construction ongoing, and then it's lacking of the ESCP, and then subsequently the sediment is washed out. Of course, at the existing settlements, the discharge from the houses with the nutrients and also the oil and grease, you are causing the brackish water, and then due to the poor drainage system, the water is still stagnant inside the drain. And then this is at the covered also we can see is the stagnant water, and also with the some of the floatable. And then at the more remote area, of course sedimentation also could be seen at the covered. So basically in terms of the point sources, there are about 84 point sources identified within the 64 km square of the study area. Next. At present, the study area, about 14.45% of the area actually is urbanized, and mostly the urbanized area is located along the Pan-Borneo Highway, and also at the southern part here where the Saliran town center is located. And then majority of the area still in the forest. But with the introduction of the Sarawak ART, the automated rapid transit train system, it will extend into the Saliran to this study area. So we expected that in the next 30 years, it will be further developed due to the improved transportation network. So by 2050, it's projected that the urban area will increase to about 45.9%, about more than 30% increase. And then actually the forest reduction is quite significant, more than 50%, to give way to the agriculture and also the urban area. So with the expected urban area to take place in the study area, we can expect that the flood and the pollution issue will get worse in the future. Next. So to address the problems in the study area, and we try to minimize the urbanization on the stormwater environment, and also at the same time we also try to strike a balance between social, economy, and also the environment, and for the sustainable development in the future. There are three main study objectives as have mentioned previously. The first one, we are looking at the water quantity. Water quantity aspect, we are looking at to formulate the long-term stormwater management and also the drainage master plan to reduce the flood risk. And then another aspect we'll be looking at is on the water quality, to formulate the long-term plan using the best management practice to reduce the pollution impact on the water body. And the third one will be on the asset inventory, where we would like to develop the stormwater asset inventory system for all the assets within the study area. Next. So to carry out a comprehensive study, it actually requires various input, analysis, and also using the numerical software for the modeling and the expected output. So in this study, the main study component is the runoff quantity control to address the water quantity, runoff quality control to address the water quality, and we have some other supporting study components to complement the main study component, like erosion and sediment study, geotechnical analysis, M&E, land use and demography, environment and landscape. So under the runoff quantity control, actually we further go into details like river hydrology analysis until the drainage analysis, and we are using the recent modeling software, and then we are using the 2D modeling to come up with the flood mapping and also the extent. So basically the main output from the Pisma will be the structural and the non-structural measures, and then we have come up with a cost estimation so that it can be used for the budget planning in the future. And also we have the implementation schedule. We have identified which area need to be as a priority to be implemented to solve the flood problem and the water quality problem. And we have other deliverables like the stormwater utilization plan, mostly to for the non-potable usage, and then the SAIS and public awareness. Next. For the overall 64 km² of the study area, to ease in the analysis, we actually divided into 8 drainage zones. The zoning actually is based on the river that the drainage drain into it. Like on the most northern part, where the drain actually drain into Sungai Tarat, Sungai Munjin. So we actually grouping it according to the river zone. So under the existing land use is about, we further divide to about 112 existing subcatchment, and then with the future urbanization, we further demarcate another 81 subcatchment. With the total, we have about 193 subcatchment for the 64 km² study area. Next. Okay. As the runoff quantity control is the main component in this study, the scope of our analysis, basically we are focusing on the main drain and also the secondary drain. The main drain, actually we are looking at to convey the runoff towards the river, while for the secondary drain actually is to convey the runoff into the main drain. Of course, in this case, we also try to look at the river capacity. As there are times that when the river water level is high, the internal drainage, indeed it cannot drain out into the river. So for the overall runoff quantity control, we have started from the river hydrology analysis to derive the inflow hydrograph as input into the river hydraulic model. We actually simulate from the 2-year until the 100-year ARI for the existing 2020 land use, and also for the future 2050 land use. And then to account for the uncertainty in the future development, We also consider the CCF factor in the analysis for the future scenario. And then under the river hydraulic analysis, we try to establish the water level and also the discharge. As many of the times, sometimes the flooding if actually is caused by the internal drainage is caused by the high water level in the river, then the drainage cannot discharge out. And there are also times that the water level from the river backflow into the internal drainage and causing the flood. So in this case, a river hydraulic analysis is carried out to establish as the tailwater condition for the drainage. And to how we are incorporating the river hydraulic tailwater, we actually is looking at the frequency of coincidence. We are looking at the catchment area ratio between the river and also the drainage. So for like, let's say for the minor storm design, we'll look at the catchment ratio and define what would likely the ARI at the river, and then for the drainage is 10 years. Of course, at the major storm, when the drainage is designed at 100 years, we would like to look at what is the likely ARI for the river. And then for the 193 subcatchment demarcated for study area, we actually derive the peak discharge for each subcatchment using the acceptable hydrological method, like the rational method for catchment area less than 80 hectare, and then time area method for more than 80 hectare, or for those catchment area that will involve in the storage. From here, we proceed with the drainage hydraulic analysis, and then our findings are basically to assess whether the drainage is having the sufficient or insufficient capacity. Next. So one of the important assessment in the study is the drain capacity assessment. So from the compilation for the study area, the total drain length for the main drain and secondary drain is about 60.8 kilometers long. So we actually do the assessment from the 2 year until the 100 year. But in this case, we are presenting the major finding, under the major storm, the 100-year ARI. And there are two scenarios. One is at the existing 2020 existing land use condition, and then we have two conditions. One is at the normal tailwater at the river. As we can see on the top left, at about 53% of the drain actually is sufficient. When the water level in the river is not so high, it can drain out freely to the river. And if coincide with the high tailwater in the river, about 71% of the drainage is insufficient. And this case, at the southern side of the study area, actually is caused by the high water level from the Batang Sadong. Even at 2-year ARI, a lot of the internal drainage indeed cannot drain out. For the northern side of the study area by the Batang Sadong tributary, it actually is coinciding with about 10-year ARI river water level. And then with the future urbanization to take place, more drainage actually is having the insufficient capacity. It will increase to about 56%, assuming it's still having the same size, but to receive the additional flow. So and then it will cause the drainage insufficient and overspill. And for the high tailwater condition, it will increase to about 76%. Next. So from the drain capacity assessment, we actually also proceed with the 2D modeling. This is the 100-year flood inundation map. At present, under the 100-year ARI, we can see that the flooded area is about 13.77 km², which is about 21.5% of the total study area. Basically, we can see that at the southern part of the study area is quite a more extensive flooding. This is because of the high tailwater from the Batang Sadong. And then at the northern part of the study area, basically is although it is overspilling, but actually at present it will be overspilled into the green area and undeveloped. when come to the 2050 land use condition, assuming the flooded the development will be developed within the existing terrain, the flooded area will increase to about 13.9%. 13.9 terrain square or 31.7%. Next. So to propose for the overall the runoff quantity control in the study area, there are two main guidelines that we are referring to. One is the Urban Stormwater Management Manual for Malaysia, the MSMA second edition. Besides, for Sarawak, they have developed their own urban stormwater management guideline known as the SASTOM. It's the second edition. We also referred to in the formation for the runoff quantity control. So to reduce the flood risk in the future, we actually propose a mixture of the structural and also non-structural measures. For the structural measures, basically is to provide have the immediate effect to solve the flooding. We have detention storage, which is in line with the MSMA concept control at source. Because with the introduction of the MSMA, we have shifted away from the traditional rapid disposal approach to control at source approach. And while some of the area is with the provision of the detention storage, we also have the some for flood protection through the bunding and pumping. This is especially critical at the southern area. Of course, if with all these measures it still cannot solve the flooding, we have to improve the main drain conveyance. So basically, the main design criteria will be for new development, the post-development peak discharge must be same or lower than the peak development peak discharge. Studying that there are still some space allowed for the future development. So we are adopting the 100-year AI design for the study area. And actually for those existing natural waterways or drainage as the earthline, we try to maintain it as possible. And to ease the future maintenance, we also propose a river and also the drainage reserve. Besides the structural measure, we also emphasize a lot on the non-structural measures, like future development platform to be above the 100-year flood level. And also we try to gadget some of the drainage reserve to preserve the existing floodplain. And of course, we also try to encourage the stormwater utilization for those the non-potable usage. Next. Okay, so for the overall study area, the runoff quantity control master plan, we have about 7 major components. Of course, the first one will be the detention storage, about 27 numbers of the pond, account for area about 208.8 hectare, and then drainage upgrading is about 29 kilometers long. And then for the future development, we actually try to intersect those the future development we have having the new main drain to drain into the detention pond first before it drain out to the river. Of course, at the southern side of the study area, which is seriously be flooded every year, we cannot besides solving the internal drainage, we also propose some river improvement work. Without the river improvement work, the internal drain stormwater management master plan cannot be effective. So there was some improvement work proposed at the southern side, and with the river improvement work, we actually to have the provision of the floodgate and also the pumping to pump the water out from the internal drainage to the river. At present, in the study area, there is one quite a big pond named as Tasek Danu. But Tasek Danu actually is developed not for the flood control. So some may worry in the future there will be so many ponds in the study area. But actually, when it comes to the detailed analysis, For this 208 hectare of the pond with about 27 number of the pond, it actually just account for about 5% of the study area only. So actually it's also in line with the those development required, where about 10% of the green area to be allocated in the development, and then the proposed detention pond can be integrated into landscaping and recreation to increase the functionality and also the usage. Next. So basically, with the proposed stormwater management and drainage master plan to address the flood, we activated with those master plan, and also with if those measures are being implemented at site, the flooding area could be reduced from 13.9 km square to about 7 km square by year 2050. Of course, as shown in the map here, those gray shaded color is the future area to be developed. So basically they will be protected from the flood, and then and also based on one of the important non-structural measure where the future development to be platform level to be higher than the 100-year AI flood level. Next. In the study, one of the important deliverable will be the platform level for the study area. So actually based on the submission checklist for stormwater management in Malaysia under the MSMA first edition, it's mentioned that for the habitable flow level of the building, it shall be set above the 100-year AI flood level with the 0.5 meter freeboard. So from our analysis in the future 2050, considering the high tailwater condition of the 100-year AI, we have come up with the minimum platform level to as a reference for the local government and also authority to refer for those development to be take place in the future. So this will be served as a guide, and this can actually avoid in the future some of the development to be over backfill to a much higher level, and then causing transfer the flood to downstream. Next. Apart from the runoff quantity control, there is another important study component is a runoff quality control to address the pollution issues in the study area. So of course we will start with the data correction, and then with the desktop analysis like the pollution loading calculation using the EMC method, and then also we use the software like the music, which is the model for urban stormwater improvement consideration developed in Australia to simulate the non-point source pollutant transport and also the routing. And then from the model simulation, we try to compute what is the present loading under the 2020 and then projected 2050 loading. From here, we try to come up with the strategies, how much pollutant need to reduce according to the MSMA reduction target, and subsequently formulate the master plan. Next, the importance of this runoff quality control indeed is we try to preserve the existing water quality and not to deteriorate the water quality due to the urbanization in the future. Next. So we consider water quality. We consider of two parts. First part is on the river water quality. Alright, within the study area, there are some of the existing monitoring water quality station by different agencies, DOE and also NREB. So a long-term record have been obtained from this agency, and basically we can see that Batang Sadong study area is having a very good water quality. The average WQI is about 85.4, and actually 93.5% of the time they are actually within the class 2 range. So indeed for Sungai Batang Sadong and also Sungai Tarak, they are having a very good water quality. This good water quality should be preserved so that it should not be deteriorated in the future due to the urbanization. Next. Okay, in this study we actually carry out the drainage water quality study because there is no existing drainage water quality data available within the study area. So we actually carry out at the major land use like the agriculture, residential, open space, industrial, and kampong. And actually for each of these land use, we actually carry out during the raining time to establish the EMC value. And for each site, actually we have select 3 storm event. And then at each storm event also, we have at least 5 samples. We try to cover the first flush, and then during the rising of the water level, what is the concentration, and also during the recession time of the water level. So from the study, we can generally see that for the TSS parameter, kampong area actually having the highest value of TSS, about 158 milligram per liter, which actually is in the class 4 already if we compare with our national water quality standard. And then for the total nitrogen, generally it will be high, could be observed higher at the agricultural land use and also the kampong. For other land use, it's just about an average is about 7 milligram per liter. The study is having quite a low total phosphorus. Generally, it's less than 0.2 milligram per liter, and this is indeed within the class 2 limit. Next. Okay, we using the sample EMC value, we actually proceed with the pollution loading calculation, and then subsequently verify using the MUGIT software. So we actually carry out the model calibration and verification to ensure it's able to reflect the existing water quality condition within the river, the study area. So we compute the pollution load under the 2020 land use and also the 2050 land use. Generally, we can see that average TSS loading in the future will increase about 22%. So actually, if this additional loading, if discharged into the river, it may cause burden to the river and seriously deteriorate the water quality. For the TN, average it will increase about 30.6%, and then for TP is about 62.5%. So actually, for the loading have a higher increase, like in the TN and TP is at those drainage zone that is likely to be urbanization in the future at the northern side, like the Sungai Munjing, Sungai Tarak, and also the Sungai Ryan area. Next. Okay, next we also try another important analysis that we adopt in the is this another study analysis component that we involve is the erosion and sediment analysis. Okay, so actually for erosion and sediment analysis, we actually try to identify areas that are at the potential risk, and then with the extensive soil erosion. And we also try to estimate what is the soil loss value according to the land use. Because at the present, the some of the drainage actually is quite severely sedimented. So it can be deduced that there's a silver erosion from the land side, and then the sediment is washed off into the drainage. So basically we can see that under the existing 2020 land use, the average soil loss rate is about 8.8. If according to the DOA ranking, this is actually considered low. The only have the slightly higher soil loss is by clearland, and for clearland there's just about 3.4% of the existing area is on the bare land condition. And then in the future, assuming the bare land condition will be developed, and then you have the changes on the soil loss, and generally we can see that because of reduction in the forest and give way to the agricultural development and also the urbanization, the average soil loss will be increased to about 66.6 ton per hectare per year, and this will be changed the class from the low ranking to the moderately high. So with such anticipated to be happen in the future, it's important to have the BMPs to reduce the erosion and sediment problem in the future. Next. Okay, so after analyzing, there's a increase in the pollution problem and also the sedimentation. So for the overall runoff quality control master plan, we have come up with a mixture of the structural and also the non-structural measures. So actually the non-structural measure is the technique that we try to reduce the quantity and improve the stormwater quality at its source using the BMPs. This actually can solve the problem with the immediate effects. And then for the non-structural measure, indeed is to ensure the sustainability through the land use zoning or the awareness to reduce the pollution to the drainage and then to the river. As stated in the MSMA, the pollution reduction target that we are looking at is on the potable, which is actually 90%, and then followed by TS 80%, total nitrogen and total phosphorus at 50%. And then during the formulation of our runoff quality control master plan, we also try to integrate between quantity and also the quality. Let's say some of the proposed BMP, it actually can have the achieve the dual objective, improve in terms of quantity and also the quality. And of course, the BMP that we propose also have to be economical and then easy to maintain in the future. Next. From the various analysis that we have carried out and also the various options that we have proposed for the study area, finally the option adopted for, as the runoff quality control master plan for the study area is the optimum BMP proposed, and then we can achieve the class 2 at the drainage site before we discharge into the river. So basically the major component will be the water quality pond, and about 26 number of the ponds are proposed, and actually they are integrated into the detention pond. So actually you have the dual function. Besides quality, they also have the take care of the quantity aspect. And then at the incoming drains, incoming ponds, we have the GPT to reduce the floatables and also have the sediment phobia to reduce the sedimentation. Of course, when we talking on this optimum BMP to achieve the class 2 for the study area, one thing that we have not achieved is on the MSMA pollution reduction target. But after we have cut out, analyzed the overall water quality status for the river, if really to comply with the MSMA reduction target, you have to provide more BMPs to achieve the target. As a result of this, you may have more BMPs, and then you have more BMP will be more costly, and also more operation and maintenance need to be taken care of. But in this case, we actually looking at the optimum BMP, where we actually can achieve our objective, and then at the same time, we strike a balance between the cost and also in terms of implementation and also the maintenance later. Next. Okay, another important output from this study is the stormwater asset inventory system. So basically, as shown here on the study area, we actually zoom in for the drainage into about 26 number of the index max. From the assets available in the study area is about main drain is about 112. Secondary drain is about 254 numbers, and cover 131. And then we actually developed the whole system in the ArcGIS interface, where it can become a dynamic and a live system to be continuously to update in the future. Besides, we putting in the existing asset information like the length, the width, the depth, and also the ownership. Actually, ownership is is one of the important in the component in the stormwater asset inventory system, where we try to identify who own the drainage and also the asset. So through the engagement with all the government agency within the study area, we managed to classify the ownership to JPS, JKR, JBAP, and also Majlis. Of course, there are some minority of the drainage actually is on the existing agricultural area, which have not have the ownership, but we actually do the recommendation for the future maintenance. Inside the system also, apart from the existing asset, we also incorporate in the proposed BMP under the runoff quantity and runoff quality control, where for this one in the future, it can be used as a reference to check whether the location proposed as the pond, what is the detail available. So besides the hard copy, we also have a system in the GIS that to ease the process in the future for increase the efficiency and also the decision making. Next.
Okay, thank you, Engineer Judy. Next, I will come back. I come back for a brief conclusion. At the end of our presentation, I would like to stress that Pisma manage development at micro level, which is at city, focus in the city. Pisma assists land manager for sustainable development, controlling problems at source, and preserve our nature for the future generation. So Pisma enables sustainable development with mitigation to reduce the risk, control quantity and quality in the future development. Pisma shall be referred by city developers as a primary reference for future development. So with that, I end our presentation, and thank you.
Okay, thank you, Ms. Karin and Engineer Judy. So we now come to a question and answer session. So allow me to read first question from the viewer in the Zoom. The question is for Engineer Judy. What is the normal and high tailwater that you have used for the study?
Okay, in this study, for the normal tailwater, we are actually adopting the normal tailwater water level in the river. And then for the high tailwater, we actually do the probability, calculating the joint probability of coincidence. Let's say the drainage is having the certain catchment area, and then the river at that catchment area, what is the catchment area? So referring to the catchment area ratio, we calculate the joint probability. So actually at the southern side of the study area, most of the drainage, when they are having the 100-year ARI, the Batang Sadong actually is having the 2-year ARI water level. And then at the northern side, for those smaller tributary, when the internal drainage is about 100-year ARI water level condition, the river actually is experiencing about 10-year ARI flood.
Okay, thank you. Second question. Did this study consider river high water level during the heavy rain? And if yes, how long can water be stored before flooding occurs if the river water level is high? Maybe Miss Judy can answer this question.
Okay, actually, for this one, we actually looking at case by case again. At the southern side of the study area, where it's drained by the Batang Sadong, the critical storm duration for Batang Sadong is about 48 hours lah. So in this case, is with a heavy rainfall and then with a long duration of the high water level, we have proposed the pumping to pump out the water from the internal drainage to the river. And then at the northern side of the study area, drained by the tributary, basically on average is about critical storm is about 3 hours. So we actually propose the storm water to be stored in the drain, the pond first before it drain out to the river.
Okay, before I proceed to the next question, I just want to know, were there any challenges or difficulties that you have encountered while producing the Pisma? We're referring to the case study.
Actually, for this Pisma study, when it's in the Sarawak state, I think the major challenges that we are facing is the data limitation, because in Sarawak, there are some of the data that is not so easy to be obtained from the respective government agencies. So we have to make our engineering judgment and also the to justify what is the assumption need to be adopted in the analysis. And another one is the planning horizon is for about 30 years. So from the existing condition 2020, we have to try to think what will happen in the 2050. And if based on just studying from the historical trend, you may not anticipate the very drastic urbanization to take place in the future, but we have to make certain assumptions to make it to happen in the future, and with the limited data that we can obtain from the local government on certain of the data. Of course, we have involved in numerous Pisma study. For every Pisma study, the expectation actually also is different. So, and for each study area, the problems they face is also different. So we have to come up with the solutions that can specifically address the problem faced within that particular study area.
Okay, I think thank you, Miss Judy. Now I would like to go to Miss Karen. So what do you personally think on how to promote Pisma besides MASMA?
Okay, MASMA, of course, is a general guideline that we can refer to on our design. So Pisma is a specific study, master plan study for a specific township or a city that we have performed, and we have proposed what are the measures, the plans, long-term plans in terms of like water quality and water quantity. So how to promote it? First, of course, once a Pisma is completed, the first thing we will do is we will present the report, the master plan to the local authority, respective local authorities, and the stakeholders. We will present to all related local authorities and stakeholders, mainly to make sure that they are aware of the study. They know that, okay, that is such master plan available, and so that they can refer to all the deliverables that we have like presented by Engineer Judy. For example, the flood map, the stormwater utilization map, and also the minimum platform proposed minimum platform level. So this is important reference for them in order to make decision on future development planning. And also, like if there's any application from the public for development approval, so they can refer to all these documents in making correct decision. So of course, like throughout like our study period, we will do like public engagement, which we will talk to the public, and we will promote our study. And at the end of the study, like we will make sure that the public is make available of these documents, especially all those like important documents like the deliverables, the output of the deliverables. So besides, like we will try to like we're trying our best like to share our knowledge and share the findings of this master plan. Like today's like webinar, we try to present the findings of each master plan for each city one by one, like through our platform, like our JPS platform webinar. So we hope that like with that we will share more knowledge on how a master plan is done and what are the suggestions that we have made through the master plan. So I hope with that, with all this effort, we are able to promote the master plan. I mean, like the Pisma. This is a very challenging task, but we hope that like more people will get to know about this, and the public will be able to get benefit from our study. Thank you.
Okay, thank you, Miss. So after promoting the Pisma, how was the feedback so far from the state ID, local authorities, or perhaps other relevant agencies on Pisma? Maybe Miss Karin can answer that.
Okay, thank you. So after we have presented the master plan, so for the area or the district that have this master plan, so the JDs, the Juruterra Daerah, the district engineer, they have more reference. They have more reference in making decision. First, they will know that if like under 100 ARI of flood, so which area is expected to be flooded, and they will know clearly that what are the extent of the floodplain in that area. So with that, they can make use of this information to carefully plan the implementation of the drainage system or any infrastructure within his area. So this is like in terms of JPS, how our district engineer can make use of the master plan. In terms of like our local authorities, especially Majlis, they can make use of our the minimum platform level map to give a correct decision approval on what is the minimum platform level that a new development should build on. So this is basically these two points that they can do it. And thirdly is besides that, like of course, like in terms of desktop study, we will know better on like the hydrologies and hydraulics of the area, and we will know that like actually sometimes we will know clearly when one area get flooded, what is the main reason and what is the actual reason of the problem. Okay. So
Yeah.
I see in the Q&A, one of the question asked is like, how do we want to apply for a Pisma of the district? When I read the question, I'm thinking of like, I think the audience is asking, how do we apply a new Pisma? Is it? Or is it like, how do we make use of the Pisma? If how to make use of the Pisma, I have answered previously. So if you're asking like how to apply a new Pisma, so we would say that like Masma Bagian Saliran Mesra, we have reference and also a standard TOR to how to how to apply for Pisma, and we have a standard procedure how to gazette the study area and define the study area that we requires. So, and we have a list of checklists where what information and budget that we need for to implement a master plan study. So if you are interested, you can come to us and talk to us for further details. Thank you.
Okay. So another question. As we know, there are three main objectives of Pisma, like Ms. Kenny had mentioned just now. So what is the most important criteria in producing Pisma? Maybe both of you can answer this question.
Maybe Engineer Judy, you can start first.
Okay, in terms of the three main objective, I think all the while we actually is looking at flood will be an important aspect to looking at. But actually, there are times that we actually forgot about pollution. As like the reason, there's quite a number of the cases where when the fresh flood occur at a certain site, actually it's not because of the drainage having the insufficient capacity, but rather is causing by those rubbish or those floatable actually accumulative inside the drainage and then causing reduced capacity and causing flood. Of course, there are times flood we are emphasis, but we also cannot neglect on the pollution issues.
Yeah, I do agree with Engineer Judy on the importance of all objectives. Like none of them are like most important, so they are all equivalent important. So and all the main objective of Pisma is interrelated as well. So like if we have developed the stormwater asset inventory system, so it will enable us to optimum our maintenance plan. So it will provide we will have ability to plan our maintenance plan and run the implement the maintenance in the drainage system, existing drainage system, so that it won't cause clogging in the drainage system, and so that we will provide efficient capacity of the existing drainage system. If so to not to provide not to cause any blockage in the drainage system. So this is they are interrelated actually.
Okay, thank you. There's another question from in the Facebook Live mentioning they want to know the possible method in MASMA in applying a lowland area when they have facing the banjir termenung in their area. Maybe this is out of context, but maybe Ms. Karen or Engineer Judy can answer that question.
Okay, when an area occurs like banjir termenung, meaning that the flood water does not subside in long time, I would say that. So like first we have to come back we have to study the specific area, what happened, what is the topography of the area, and what happened actually, what is the causes actually. So if the banjir termenung is because of like clogging of the drainage system, so we just maintain the drainage system. So but if the flood is due to like insufficient capacity of the drainage system. So we have to upgrade the drainage system. But if the the flood is because of other reason, then we have to find out other solution for the problem. So we have to look into case by case, I would say. So we have to look into what happened and what is the main causes of the flood actually. So I would say, as I gave 2 examples just now, so we have to look at what are the causes, and then only we can come up with the proper solution. Yeah, thank you.
Yeah,
maybe Engineer Judy, do you have
yeah.
other points or other things that you would like to add in?
Actually, just add in for each of the site, they have their unique characteristic. Of course, we cannot apply the same approach for all the sites. So we either have to go into the root cause, what is the causes, before we can come up with the solutions. Because in general, if we come up with what is the general method to solve, it may not be applicable for that site. So I think it's better to identify what is the causes of the flooding before we can identify the suitable solutions.
Okay, next question. I think maybe this is the last question because I didn't receive any questions at this time. We know that DID has produced a lot of master plan such as IRBM and ISMP. So what makes Pisma is very unique on its own? Maybe Ms. Karen can answer this question.
Okay, as I presented just now, say for example, RBM focus on the whole basin. So it provides the strategy and objective in general to achieve 4 objectives: ensure sufficient water, ensure clean water, reduce flood risk, and improve the environment. So for Pisma, Pelan Induk Saliran Mesra Alam, we focus onto localized urban issues with long-term solutions. So when we say localized urban issues, like maybe the main issues we can zoom into like stormwater quantity and stormwater quality issues. So that's why that makes slightly different. Pisma is more focused on localized area. RBM is on general on the basin scale. So if like ISMP is on shoreline, so like the problems like or issues faced and the management suggested in the ISMP. So that is for integrated shoreline management. So that is slightly different. So but when we integrate all these plans, master plan together, it is for the good sake of like our whole country. Yeah, I should say that.
All right. I think that's all the question that I received for today. But before we end the session, any talk that Miss Karen or Miss Judy want to say on our session for today?
Okay, maybe I will start first. So like today's webinar session is on Pisma, the status. We are just sharing the problem and status of Pisma in Malaysia. What are the status? And we are working hard towards like to have Pisma for all the cities, all the towns in Malaysia, around Malaysia. So, but due to budget constraint and also like manpower, so we are working very hard towards like that. Today we have shared the study findings from Pisma Saliran. So I would say that like the findings from Pisma Saliran should at this moment is our baseline and benchmark for the other Pisma. So we will always use Pisma Saliran as our benchmark and reference for other Pisma, so that at least they have to achieve the same standard of like studies. So I appreciate a lot and thank you a lot for Engineer Judy today to join us for sharing, and also your team, your whole team I believe that they have worked very hard throughout our study period, because like we know that when the study started in March last year, it is when our MCO start as well. So they have a lot of difficulties and they face a lot of challenges in terms of like getting data and going to the site, but they struggle, but however, they managed to perform the study perfectly. So I hope that like in future, like we will have more sharings with other consultants on other study. So we will come back to we'll come back on other webinars presentation later on next time in the future. Thank you.
How about Miss Judy? Do you want to add on anything?
Okay, actually, this is okay, not the first Pisma that I am involved in. To me, I think Pisma is a good study because it actually emphasize a lot on the MSMA, and MSMA actually it actually have shift away the from the rapid disposal approach to the control exhaust. And actually sometimes like just at my neighborhood there's a detention pond actually with a very nice landscaping. Besides for the flood detention flood control purpose, it also provide another opportunity for the recreational. So if we try to just not look at the flood control only using the MSMA concept, it actually can have a lot of the benefits. And also for Pisma, actually you are looking at a more localized study area, a smaller scale, on a city scale. Actually it can we can really focus on the problem faced in the study area. Of course the findings it can be later on we incorporate into other study like the river IRBM or river basin, because inside the river basin also you have certain city development. So actually it can be integrated from the small micro scale to the major scale. So I think and then for the Pisma, if it can be as a guidance for the local governments authority to guide them for the future development approval, it will be good. And after there's another things that can be looking at is maybe after some times there's time to review back on the proposal that proposed whether it's still feasible. When we continue develop the new Pisma, for some of the Pisma that have been completed, maybe we can try to look at whether there's a need to revise, take it into account of the recent development. It's just my point of view.
Thank you very much, Ms. Carrie and Engineer Judy. So I think that's all for now, and I hope all viewers have enjoyed and gained informative knowledge, especially on Pisma after listening to the speakers. So on behalf of the Secretariat, I apologize should there be any shortcomings throughout the webinar. Once again, thank you for joining us. And if you still have more questions or want to know more on Pisma, kindly contact us through our DID Facebook or the Stormwater Division staff. Till then, I would say have a good day, everyone, and salam hormat.